Assalamualaikum warahmatullahi wabarakatuh. My name is Najwa binti Muhammad Zaini from Group 1. Today I will present differentiation. My group member is Nurin Shira, Nadirah Nurdamia, Kistina and Siti Nur Zunaira. Today we will present to you introduction, filler table, problem background, solution of study and conclusion. Introduction. Differentiation is referred to the process of finding the derivative of function, which represent the rate of change. The process of differentiation involves applying rules and formula to find the derivative of various types of function, including algebraic, trigonometric, and exponential function. Differentiation has various applications, including finding the slope of tangent line to a curve, determine maximum and minimum value of function, and calculating velocity and acceleration. One way to differentiate is to determine the difference of quotient limit. To calculate differentiation, you apply differentiation rules and formula to a function. Common rules include the power rule, sum rule, product rule, and quotient rule. The power rule state the derivative of xn equal to nx n minus 1. The derivative of constant is always 0. The other basic rule, called the chain rule, provide a way to differentiate a composite function. There are also other methods to differentiate the equation in a condition of multiply, which is product rule, and for equation that need to divide, we use quotient rule. This is the differentiation table. So when we differentiate the equation, we need to refer to the differentiation table.
Assalamualaikum, my name is Kistina binti Muhammad Nasir. Today I will explain about our filler table. The first fact is the oil spread is circular. Use A equal to pi r square. The issue is how to differentiate area with respect to time. So we need to differentiate the A equal to pi r square. For the second fact is radius is 5 meter and it increasing at 2 meter per square. So we need to use chain rule, which is dA over dt equal to dA over dr multiplied by dr over dt. So the issue is how to use the chain rule. We need to substitute the r equal to 5 and dr over dt equal to 2. For the third fact is piston position is st equal to 2f minus 5t plus 8p. Velocity is the first derivative. So how to differentiate a polynomial function? We need to differentiate the piston position to v equal to dt square minus 10t. For the last fact is the position is in meters and time in second. The idea is acceleration is the second derivative. The issue is how to evaluate velocity and acceleration at a specific time. So we need to differentiate once again the first derivative.
Hello, my name is Siti Nur Zunaira and I'll explain of task 1, which is question 1. So from the question, we got the information. So the first thing is the radius of tumpahan minyak is 5 meter. And then we got the constant radius is 2 millisecond, which is dr over dt. And then we assume that the tumpahan minyak is in sphere, is in circle. So the formula of area circle is pi r squared. And then we differentiate the area because we want to get dA over dr. So we get 2 pi r. And then lastly, we conclude that the formula is dA over dt equal to dE over dr multiply dr over dt. So dA over dr is 2 pi r multiply 2, which is dr over dt, and then we got 4 pi r. So 4 pi r we substitute with 5 meter, and then we got 20 pi meter. And then the final answer is 20 pi, or in per second.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ishra binti Muhammad Syahizam. My case number is AE240892. So the problem for task 2 is a piston in an engine move according to the function S equal to 2t cube minus 5t square plus 8t, where S is the position in meters and t is the time in seconds. So we need to find the velocity and acceleration of the piston after 2 seconds. Next, for the solution for task 2, first, we need to write the function which is S equal to 2t cube minus 5t square plus 8t. And then we need to differentiate the equation to get the equation of V, which is V equal to 6t square minus 8t plus 8. And then we need to substitute t equal to 2 into the equation V. When we substitute t equal to 2, we get V equal to 12 ms negative 1. And then to find acceleration, we need to differentiate one more time. So we need to differentiate the V equation, which is V equal to 6t power of 2 minus 8t plus 8. And then we differentiate and get A equal to 12t minus 10. And then after we get the equation for the acceleration, we need to substitute t equal to 2 one more time again into the equation. So we get acceleration is 40 ms the power of negative 2.
My name is Nadia Nordama Bitok Malik. I'm going to talk about discussion. In task 1, the problem is where the oil sprayed in a circular pattern. To determine how fast the area of spilling oil, we need to use the area of the circle. Given the data radius meter and increasing constant at rate is 2 meter per second, substitute the value into the formula, thus we could get the final answer. In task 2, the question asks to solve the problem of a motion in a piston in an engine by the position function given, where S is in meter and t is in second. Based on the question, we need to find the acceleration at t equals to 2 seconds to find the velocity. We need to derive the function. After that, we could simply substitute t equals to 2, thus we can get the answer. Lastly, after we get the answer, we can finally get an acceleration at substitute t equals to 2. From task 1, we could conclude that the rate of change of an oil spreading in a circular pattern can be calculated using basic differentiation. This helps us to understand the concept more, especially in our daily life. For example, we could simply substitute the information in the formula and set the range of answer. In task 2, we learned that by applying the formula and understanding the question in the motion function, we can find the velocity and acceleration from the data given, which help us to calculate the range of spreading oil to avoid danger around the area. After all, both situations show the importance of analyzing change in our daily commitment. This calculation help us to describe change, also predict the outcome of the situation in decision making.